Welcome back to Prep Forge. We've covered Kafka and RabbitMQ. Today we finish the trilogy with Amazon SQS, the simple queue service, the most widely used managed message queue in the cloud. Here's what makes SQS different, and what interviewers love about it. There are no servers for you to run. AWS operates the whole thing. But that convenience comes with rules you have to understand, especially visibility timeouts and delivery guarantees. In this video we'll cover standard versus FIFO queues, how a message actually flows, visibility timeouts, polling, delivery guarantees, dead letter queues, the key limits, the code, and finally when to use SQS versus SNS in Kafka. Let's get started. Let's start with why SQS exists. Imagine your checkout service needs to send an email, update analytics, and notify a warehouse. If it calls each of those directly and one is down, checkout fails or hangs. That's tight coupling. A queue fixes it. Checkout drops a message into SQS and moves on. A worker picks it up later. Now here's the SQS twist. With Kafka or RabbitMQ, you run and scale the broker yourself. With SQS, there is no broker to manage. It's fully managed, and effectively infinite in scale. You just call an API to send and receive. That trade, giving up control for zero operations, is the whole reason teams reach for SQS. Concept 1: Standard versus FIFO queues. This is the very first decision you make with SQS, and it's the most common interview question. There are exactly two queue types, and they behave very differently. A standard queue gives you nearly unlimited throughput. But it makes two compromises. It guarantees at least once delivery, which means you can occasionally get duplicates. And it offers only best effort ordering, so messages can arrive out of order. A FIFO queue, whose name ends in .FIFO, flips that. It guarantees ordering, first in first out, and exactly once processing, so no duplicates. The cost is throughput. FIFO queues are capped, though batching raises the ceiling. The rule of thumb to say in an interview: use standard by default for maximum scale, and reach for FIFO only when order or deduplication genuinely matters, like financial transactions. Concept 2: How SQS actually works. 3 operations, and one of them trips up almost everyone. The flow is send, receive, delete. A producer calls send message to put a message on the queue. A consumer pulls the queue with receive message and gets one or more messages. Then, and this is the part people forget, the consumer must explicitly call delete message once it's done. SQS does not remove a message just because you received it. If you never delete it, it will come back. That deliberate design is what makes SQS reliable. A crash before delete simply means the message reappears for another worker. Concept 3: The visibility timeout. If you learn one SQS mechanism deeply, make it this one. It's the single most asked SQS question. When a consumer receives a message, SQS doesn't delete it. Instead, it hides the message from other consumers for a period called the visibility timeout, 30 seconds by default. The idea is, while you're processing, nobody else should grab the same message. If you finish and call delete before the timeout expires, the message is gone for good. But if your worker is too slow, or crashes, the timeout expires, the message becomes visible again, and another consumer picks it up. Here's the classic trap. If your visibility timeout is shorter than your processing time, SQS will redeliver the message while you're still working on it, and you'll process it twice. Set the timeout longer than your worst-case processing time, or extend it while you work. Concept 4: Short versus long polling. This one is about cost and efficiency, and it's an easy way to sound experienced. When you call receive message, SQS can respond two ways. Short polling, the default, samples a subset of servers and returns immediately, even if that means returning nothing while messages actually exist elsewhere. That wastes empty requests and money. Long polling, which you enable by setting wait time seconds, up to 20, tells SQS to wait until a message arrives or the timer expires. Long polling reduces empty responses, lowers your API costs, and lowers latency. The interview answer is simple. Almost always enable long polling. There's rarely a good reason to use short polling. Concept 5, Delivery Guarantees in Ordering. This ties back to queue type, and it's where you show depth. Standard queues are at least once. A message is delivered at least one time, and occasionally more than once, so you must make your consumer's idempotent, deduplicating on a message ID so reprocessing is harmless. Standard also only promises best effort ordering. FIFO queues are exactly once processing within a deduplication window, and strictly ordered. Ordering in FIFO is controlled by the message group ID, and messages in the same group are delivered in order, one at a time, while different groups run in parallel. So if you key by customer ID, each customer's events stay ordered, but customers don't block each other. That message group ID detail is exactly what senior interviewers are listening for. Concept 6, Dead letter queues and redrive. This is how you handle messages that just won't process. Sometimes a message fails over and over. Maybe it's malformed, a poison message. You don't want it retried forever. So you attach a dead letter queue and set a max receive count, say 5. Once a message has been received that many times without being deleted, SQS moves it to the dead letter queue automatically. There it sits, isolated, where you can inspect it, alarm on it, and debug. Once you've fixed the cause, you use the redrive feature to move those messages back to the main queue for reprocessing. A dead letter queue is the difference between one bad message and a stuck consumer. Concept 7, Retention, Delays, and Large Messages. A few limits that come up constantly. 3 numbers worth memorizing. First, retention. A message can stay in a queue up to 14 days, 4 days by default, then it's deleted. Second, delay. You can delay delivery of a message up to 15 minutes, useful for scheduling. Third, size. A single message is capped at 256 kilobytes. For anything larger, you store the payload in S3 and put just a pointer in the message, using the SQS extended client library. And to cut costs and increase throughput, use batch operations, up to 10 messages per API call. Retention 14 days, delay 15 minutes, size 256 kilobytes. Those 3 numbers alone will impress an interviewer. Concept 8, SQS encode. Let's make it concrete with the AWS SDK for Java. In practice, you use the SQS client from the AWS SDK, version 2. You call send message with the queue URL and the body. To consume, you call receive message, ideally with wait time seconds set for long polling, process each message, and then call delete message using the receipt handle that came back. That receipt handle, not the message ID, is what you pass to delete. Forgetting to delete is the number one SQS bug, and now you know why the message keeps coming back. Concept 9, the big picture. SQS versus SNS versus Kafka. Nail this and you sound senior. Here's the mental model. SQS is a queue. One message is processed by one consumer, then deleted. It's pull-based, you pull for messages. SNS, the simple notification service, is the opposite. It's publish, subscribe, and push-based. One message is fanned out to many subscribers at once. A very common AWS pattern is to combine them. SNS fans a message out to several SQS queues, one per team. And Kafka is a log. Messages are retained and replayable, and many independent consumers can read the same stream at their own pace. So, use SQS for simple decoupled work queues, SNS plus SQS for fanout, and Kafka when you need replay, streaming, or very high throughput event pipelines. If they ask when not to use SQS, the answer is when you need to replay history. That's Kafka. And that's Amazon SQS, end-to-end. A fully managed queue. Standard for scale, FIFO for order and deduplication. Send, receive, and don't forget to delete. Master the visibility timeout, enable long polling, make your consumers idempotent, and use dead letter queues for the failures. Get those clear, and you can handle any SQS interview question with confidence. To practice out loud with mock interviews and spaced repetition, head to prepforge.net. That completes our messaging trilogy, Kafka, RabbitMQ, and SQS. If it helped, subscribe for more. Thanks for watching, and good luck in your interview.